Welcome to another session on data engineering. In our last session, we saw how we connected a Raspberry Pi simulator with the IoT Hub. In this session, we're going to see how we are able to push the streaming data into a data lake using Stream Analytics job. So essentially, you can imagine it to be a stream flowing, and we have built a canal which connects the stream and takes the water or taps the water from the stream and puts it into a reservoir like a dam. Okay. So this is what we are going to do in this particular session. So since we have deleted all the resources, because that's a good practice so that it doesn't exhaust all your credit, we have deleted the data lake and we have deleted the IoT Hub, which we had created before. We will create it again in this particular session and start a Stream Analytics job that will dump the data into a data lake. So first, let us create the data lake. We have already done this, so I'm not going to explain the steps in details in this session. If you have missed the session on creation of data lake, you can go back to one of the earlier sessions and see how the data lake is created. We'll create a resource group. The resource group should be having a unique name. We'll create a data lake. That also should have a unique name. And we are putting it in central India. We have a locally redundant storage. Next. For some reason, the validation error that is coming up. It was giving a validation problem. Sometimes it happens if the internet connection is temporarily down. So now the problem is gone. The standard one is a locally redundant storage. We enable hierarchical namespace. All other things will be default. Keys and all will be default. We'll not use any tag. It's just validating that all my entries are okay. And we're now going to create the data lake. It will take a little bit of time to create and deploy it. We'll come back after the deployment is complete. The deployment is complete. Now we'll go to the data lake. We'll create a container. Let's name this as sensor input. And this is where we'd like to put all our streaming data into. However, instead of creating a directory, we will this time create the directory programmatically. Now, why do you want to do that? Let's assume a scenario where lots of data, streaming data is coming every day, and I want to create a directory based on the date of capture of the data. In that case, it is not possible to do this manually, that every 12 midnight, a new directory is created and the data will flow to the new directory. What we want is that as soon as it becomes 12 midnight, a new directory with the new date is created, and all data starting from 12 midnight or after 12 midnight should flow into that particular directory. So that way, we'll be able to group together all the data coming on a particular date. And later on, if we have to analyze a data of a particular date, we can easily find that from the directory. We want to do that creation automatically rather than creating manually. So we are not going to create a directory here. We'll create a directory programmatically. Let's go back and create our IoT Hub. We did it last time as well. And I'm not going to explain the steps in details. Those of you who have missed the previous video, you can watch the previous video in terms of how an IoT Hub is to be created and what exactly is the purpose of an IoT Hub is also explained. So we'll use the same resource group. All our resources will be under the same resource group so that it's easier for us to manage the resources. And we'll call this IoT. And we will have it same Central India in the same region. We will not use the standard one because the standard one has is more expensive. Since we're using it for training purpose, we'll just use the free one, trial one, which allows us to give a message limit of 8,000, and there's no extra cost for this. So we'll use this one. We can leave the networking as it is. Remember to have it public access. Leave the management as is. There's no add-ons that to be added, and we don't need to have any tags. And the validation is going on. If there is no error, we should be able to create an IoT Hub. There's no error, we'll create an IoT Hub. It is deploying the IoT Hub. We'll come back once the deployment is complete. Deployment of the IoT Hub is complete. We will go inside the IoT Hub, and typically an IoT Hub has twins or replicas of multiple sensors. The purpose of these twins or replicas of the real sensors is to ensure that these twins or replicas can talk to the real sensors and get the data. But that doesn't mean they're storing the data. They're just having the access to the respective sensors in the real machines. Okay. We don't have a real sensor here. Instead, we have this simulator, web simulator. So what we need to do is to ensure that the IoT Hub has a twin sensor which will talk to this simulator. So first we'll create the sensor. We'll go under device management. We'll go to the devices. And let's name this device as sensor 1. Add a device here. Sensor 1. Nothing else needs to be changed. Save this. And I want this sensor to be a twin or a replica of this particular Raspberry Pi simulator. In real scenario, this will be an actual Raspberry Pi microcomputer, as you can see in the picture over here. So we will go to the sensor 1 and we'll pick up the primary connection string. Just copy from here. You can see what the primary connection string looks like. And you can just copy this with the clipboard. And remember to go to line number 15 and replace whatever is written inside the code with whatever value is there in the primary connection string. Note that the code should not be missed. Okay. And this will ensure that this sensor is able to talk to its twin, which is the actual sensor and actual microcomputer. So we can just check, which we did in last time. We can go to the IoT Hub. Let's check whether the data is coming or not. Normally, it takes a little bit of time to get updated. So if you just run this, we'll see that the Raspberry Pi simulator is blinking, which means that it is sending the data. As you can see, it is sending the data of temperature and humidity. And these are, of course, simulated data. And this data now can be accessed by this sensor in the IoT hub. It takes a little bit of time to update the data over here. So we can ignore this for now. We are fairly certain that the data will be captured. As of now, we'll just stop this. We'll reset this again when we need it. Remember, we have a limit of 8,000 messages per day, so we should not be unnecessarily running it. Otherwise, we'll not be able to do multiple activities on the same day. Now that we have created an IoT hub, what we need is the pipe that will bring the data from the IoT sensor in the IoT hub, which is a twin of the actual sensor, into the data lake. To do that, we have to create something called a stream analytics job. So we'll go to the stream analytics job, create a new stream analytics job. Technically, it is nothing but a query. It just picks up all these values, which is coming in stream, and puts it into a data lake in a specific format, for example, JSON or a CSV, like that. So we'll use the same resource group to collect the data. We'll name this resource the stream analytics job. So let's call it SHA. We'll use the same Central India. Now here we are going to use the cloud. Now, in reality, in many cases where you require a very low latency, a very fast response, you need to have this job located very near to the machine so that it can query very fast and capture the data and pass it on to the data lake. In that case, we would need to be the stream analytics job to be configured as edge rather than cloud. As of now, we will continue with cloud because it's a training system. We are not really worried about that much of latency. We'll leave it as it is. We'll not add a storage account here. We'll not add any tags here. Nothing needs to be done for managed identity. It will just check if all the data is okay or not, or the configuration rather, and it should be able to deploy the new stream analytics job. Just create it. And this new stream analytics job is getting deployed. We'll be back once the deployment is complete. Okay, the deployment has got completed pretty fast. So we can continue. We'll go to the resource. And what we need is in the settings, in the job topology, not in the settings, this is in the job topology. If you go to the job topology, we need to define the input from where this stream analytics job will get the data, which in this particular case is the IoT hub. Where is going to output the data? In this particular case, the output will be in the data lake that we have defined. And it should have a query that will get the data from the IoT hub and put it into the data lake. So these are the three things that we need to configure over here. So we'll go to the input. And in the input, we'll add the input, which is the IoT hub. You can see there are other inputs, including event hubs, Kafka, etc. We are not getting into those for the purpose of this session. We'll use the same subscription. We can give some other name, but I'll leave it the alias name as same as the IoT hub name, which is okay. We'll leave this shared access policy as it is. The format in which the data is going to come, that is the format that in which the stream analytics job is going to get the data, and we say we are setting it as JSON. Okay. However, remember that I want the stream the output in the data lake to come in, let's say, semi-structured format like a CSV format. Okay. So, but the input can be in JSON. So we'll leave other things as default. We'll save this. This testing whether the input is able to get the connection right? Yeah. Is it able to connect with the IoT hub, and the connection is successful? So we are done with the input. Let us go to the output now. Now the output is our data lake, which we have already created. So you can see here there are many other types of output, including a SQL database or uh, an event hub and even a Power BI. We'll see this Power BI output in one of the other sessions. As of now, we want to output it to a Azure Data Lake Services Gen 2, which also contains the data in a blob format. Uh, so the difference is that I can leave it as a blob format, which doesn't have a hierarchical namespace, but we have created a hierarchical namespace. So it is a Data Lake Gen 2. So we'll select this. We can leave an output as it is. We are calling it sensor input because we will be using this for other purposes, or you can also call it sensor output or any other name that you want to give. This is a storage account, is automatically picked up the storage account, and it has already picked up the container which we have created. Now, in this particular case, the output format is not JSON. We want the output to be in the CSV format, comma separated value. Okay. And once we have the CSV format, we know that the data is going to be stored in a semi-structured format. If it was JSON, it would have been stored in. That is also a semi-structured format, but the semi-structured nature of semi-structured format is different. Now, here is a very important thing. Remember, we said that we are going to dynamically create their directories, and we want the directories to be based on date. So here is a date format, default date format, YYYY, that means first the year, then the month, and the date. And we want this format to be taken. So what we need to do is we need to put date within curly bracket. Moment we put date within curly bracket, it understands that the path where the streaming data should be stored will be in a date format. That means the directories will be created in the date format, and the date format is this. Okay. We could change the date format also, but as of now, we'll leave it like this. And we will save this. So our output is done. It is also checking whether the output is able to connect to the data lake or not. And finally, the last part, which is the query. So you will see that when you are building the query, it is taking the input, what we have defined, and is taking the output. In case, by default, it normally takes the right input, the right output. In case it is giving some other input, then you can always go and edit it over here. You have to maintain the same name as the alias. And here is the query. Okay. So we can remove the comment part of it. So this query is a very simple query which says that select everything, all the data that you have, into sensor input, which is the data over here, which is in the data lake from the IoT. Okay. And you should also be able to see some of the data that has come in. So here, few data has come in, and we should be able to see. We can make this bigger, and so this is the data that has already come in, and this is the input. We can just test it, test the query, and see what is the output. Output will be same as that of the input. So here you can see the message ID is coming, the device ID, the temperature, and the humidity, the process time, the time at which the data was processed. If it is a very large data set, then it may partition into multiple partitions, which is typically used for scaling out, and the time when the data was queued and few other information. Okay, so this is the information that we want to store as a semi-structured data in the CSV format. Okay. We will save this query. And now what we need to do is we need to start this stream analytics job. So we will go to the overview, and there we will start the stream analytics job. Moment we start the stream analytics job, it will start collecting the data from the IoT Hub and pushing it to the data lake. So let's start the job. We can leave it as standard. We want only one streaming unit and we want to start it now. So it will take a little bit of time to start the job. We'll be back once the job has started. And once the job has started, here instead of starting, it will become running. As you can see, the job has now started running. It takes a little while to start the job, so be patient. Now we are going to run this and the data will start coming and it will be tapped by the IoT hub, and then the stream analytics job will pull it and pump it into the data lake. And in the data lake, the folders will be automatically created based on the logic that we have provided. So while this is running, let us go back to our data lake and see whether the data is actually getting stored over there or not. Go to the data lake storage. This is a sensor input that we had created. And now you see that previously this was empty. Now automatically a folder 2024, which is the year, has been created. Inside the folder, the month has been created. Inside the month, the date has been created. And now inside this, we should be able to see the data. And here is the data. Now, if you click on this and go to the edit, review this, you'll see that this data is now getting dumped as a CSV file. Now, how do you know that this data is constantly getting updated in real time? You see the size of the data. If I refresh this, the size will change. That is 4.59. If I refresh this again, it will change. You can also see it in the number of rows that it is displaying. Of course, it will display only a limited number of rows. So after some time, you may not see an increase in the number of rows. But when you go over here, refresh, you'll definitely see an increase in the size of the data. Now, what we'll do, we'll allow some of the data to be accumulated in the data lake. Now, we can do two things. First is that we can download this data and do a static visualization in any visualization tool like Power BI. That means, let's say I have 1 month's data and I can do a visualization of how the temperature has moved, how the humidity has moved, and whether the temperature, the humidity was above a certain threshold, and then what is the trend of that. These things we can do it in Power BI. However, this is going to be a static data. We may also want to do a dynamic visualization. That means as and when the data is coming, we want to visualize how the temperature data looks like, how the humidity data looks like. So both things we can do. When the output is going to the data lake, because the persistent storage, we will be able to do a static visualization. In the next session, we are going to see how to do a static visualization of this data. And the session after that, we are going to see how to do a real-time visualization of the data. So in order to download the data, hopefully we have enough data now to do a visualization. Yeah. So we can go here and we can download the data from here. We'll just download it as a CSV file. We've downloaded the data as a CSV file. And just go and check whether the uh, downloaded file is having sufficient data for us to work on it. You can go back and check that this is the data that has been downloaded, and we can do visualization on this data. What we'll do is we are going to stop the Raspberry Pi instance and also stop the stream analytics job. But we are not going to delete the resource group as of now, because we will need it subsequently to see how the real-time visualization happens. So we'll first stop the Raspberry Pi, not send any more data. And then what we are going to do, we are going to stop the stream analytics job. Uh, Different type of resources take different amount. Usually the compute resources like this kind of queries take more, charges more. So we'll stop the stream analytics job, while the resources like data lake or IoT hub, they consume less charges. So we can keep it then as of now, temporarily. We will use it for live streaming of data into Power BI to do a live visualization. Okay, but we should stop the stream analytics job so that it doesn't consume a lot of resources. Go to the stream analytics job and we are going to stop the job. It takes again a little bit of time to stop the job, but we know our data has been stored, and in the next session, we will be able to use this data to do a static analysis in Power BI.